In 2023, the world's ocean surface hit a temperature scientists hadn't expected to see for years. Not in a model and not in a projection, but in a live reading. And the interesting part is, the researchers who study this for a living were surprised too. In this video, let's talk about what the numbers actually say, where the heat is coming from, why it's outpacing some forecasts, and what's already being done about it. Climate scientists have been modeling global warming for decades. They have been broadly right about the long-term trend. But recent record-breaking heat events have landed outside the range that even specialists expected. Climate scientist Friederike Otto of Imperial College London and a co-founder of World Weather Attribution put it plainly. What matters isn't whether extremes match expert predictions. It's whether they match what people on the ground are actually living through. That's important because a heat wave doesn't hit as a global average. It hits as a city's power grid that's failing, or a construction crew pulling off a site, or a hospital's emergency room filling up. Because weather emergencies are local, even when the cause is global, like with climate change. And the 2025 study published in Nature backs this up with data. Even at 2 degrees of warming, a lower level than the world is currently on track for by 2100, some regions can experience heat, rainfall, drought, and wildfire extremes that are worse than what used to be predicted for 3 degrees or 4 degrees Celsius. In other words, the average trend is tracking close to the old models, but it is the extremes that are breaking away from them. 2023, 2024, and 2025 are now the 3 hottest years ever recorded. And the way this summer feels, 2026 is going to follow their lead. But going back to those 3 years worth of data, 1 month stands out as a turning point. December 2023. The global monthly average temperature beat the previous September record by 0.5 degrees Celsius, the largest margin ever recorded for that kind of jump, and unusually large even accounting for that year's El Niño. Scientists are still working through exactly why. The leading candidates researchers are examining include water vapor injected into the stratosphere by a 2022 undersea volcanic eruption, a drop in atmosphere cooling pollution from the shipping industry after new fuel regulations, a decline in low cloud cover, and natural year-to-year climate variability. But really, no single factor fully explains the size of that spike. This is an area of active research, not a closed case. And that's actually a normal part of how climate science works. Models get refined as new data comes in. What we do know is that ocean warming plays a huge role in setting the baseline. Oceans absorb the large majority of the extra heat trapped by greenhouse gases, and warmer oceans mean a warmer starting point for every heat wave that follows, sadly. So when the baseline shifts over time, everyday systems will start to feel it. Persistent high-pressure weather patterns known as heat domes are pushing temperatures to dangerous levels for longer stretches, and this strains power grids right when demand for cooling peaks. Emergency services see a similar squeeze, with heat-related calls clustering in the same short windows. Outdoor labor is one of the clearest pressure points. Extreme heat is increasingly treated as a workplace safety issue, not just weather. And that's particularly for people who work outdoors and in regions with fewer resources to adapt, like reliable shade, or hydration breaks, or air conditioning. This is where the data points actually touch real people's lives, and the fact that their infrastructure, which was built for one specific climate, is now operating in another, in a different one. With all that said, let's next look at what is actually working at the moment. Solar is currently the fastest growing power source on the planet. Last year, it accounted for roughly 3/4 of all new electricity demand growth worldwide. Bloomberg projects that solar will generate more electricity than any other single source by 2032. Solar, wind, batteries, electric vehicles, and heat pumps are reducing how dependent regions and countries are on oil, gas, and coal. And price shocks tied to recent conflicts have only strengthened the economic case for that shift. That doesn't mean the transition is friction-free. A global overabundance of solar panel supply, combined with new trade barriers, caused panel production to drop for the first time in 20 years. And in the United States, recent policy changes have pulled back support for renewable power and EV adoption, alongside cuts to climate research and observation funding. So the picture is mixed. There's real momentum, but there are also headwinds, both at the same time. That's not a contradiction. It's what a genuine energy transition actually looks like in progress. Nothing about this shift has ever been a straight line in any country or at any point in industrial history. So it's worth thinking about the two halves of the story together, because most coverage only gives you one of them. The physical climate system is still absorbing decades of emissions, and that means more record-breaking extremes are very likely in the years ahead, even where the long-term trend is well understood. At the same time, the tools for the next phase, so cheaper clean power, better storage, more resilient infrastructure, are all scaling faster than almost anyone predicted a decade ago. Adaptation and mitigation aren't competing priorities. Increasingly, they're running in parallel. Now, that doesn't change the near-term risk, but it does mean the future isn't a single fixed outcome. It's still being actively shaped year by year by which technologies get built and which decisions get made. So, the data is stark, but it's also not the whole story. The same decade that produced the hottest years on record also produced the fastest build-out of clean power in history. Both of those things are true at once, and which shapes the next decade is still an open question we all have some hand in answering. Thanks for watching Terra Sustina. If you want to help the channel, you can buy me a coffee. The link is in the description. Thank you, and see you again soon.